Morning, ma'am. My name is Charan Teja. I'm from CSC AML third semester, second year. Today, my topic is about analysis of shared memory priority queues with two discard levels. This talk explains what shared memory priority queues are, how they work, and what it means to have two discard levels with an emphasis on their performance and use in real time or embedded systems. What is a shared memory priority queue? A priority queue is a data structure where elements are dequeued based on priority, not insertion order. High priority items come out before low priority ones. Shared memory is a memory region accessible by multiple processes or threads. This is often used in multi-core or real-time systems where different components or applications communicate quickly. Combined idea: in a shared memory priority queue, multiple products and consumers share access to the queue, possibly from different processes of CPU. Use cases: real-time systems, example aerospace, automotive. Network packet processing, sensor fusion systems. What are discard levels? Challenge: in real-time systems, queue can overflow if too much data is produced. Consumers are too slow. Discarding strategies: to avoid overload and prioritize important data, system implements discard policies. There are two discard levels. One is soft discard level and the another one is hard discard level. Now we are going to see about soft discard level. Being primitively discarding low priority, message will when the queue reaches a threshold, example 70% full, keeps higher priority messages, maintains responsiveness. And we are going to see the second one, there is hard discard level, triggered at a critical threshold, example 90% full. Standard discarding even mid priority messages if necessary. May block new strings or alert the system. What is the purpose of these things? Let's see. Maintain system stability, ensure high priority tasks are not delayed, reduce latency for critical messages. Trade-offs and performance analysis. Why two discard levels? Memory management, performance optimization, gradual control. As I said before, there are two discard levels. One is soft discard level and the another one is hard discard level. Basically, these two perform the same discarding, but both do different types of discarding. Uh, First one, soft discarding, does does pop a message that the queue is 70% full, and the hard discard is pops a message when the queue is 90% full, and also focuses on main messages. In soft queue, it only prioritizes low priority messages. Machines of two discarding levels in shared memory, PQs. Pre-instance check, level 1 discarding logo, level 2 intermediate discard, dynamic adjustment. Incoming elements are evaluated against defined discard threshold implemently upon actual ac- actual before any attempt at instance. Level 1 discard lo- logic. Item falls below the first threshold are other discarded to save resource of interest with a very low priority, developing on system configuration and current load. Level 2 implemented discarding. Elements below the second threshold are instantly discarded, prioritizing them for consuming any valuable queue or processing capacity. Dynamic adjustment. Dynamic threshold can be dynamically updated, allowing the queue to attempt the functional loads on the system in priorities. Implementation conditions. Structural choice, optimization techniques. These are the two choices for the implementing process. Now we are going to see structural choice. Memory, selecting between configurations array and linked structures based on accepted using patterns. Employing lock-free algorithm or fine-grained locking mechanism to minimize content and ensure high concurrency. Optimizing techniques. Front-end coding. Developing compact and fast methods to repeat priorities, enable rapid comparison and discard decisions. Data faking. Using techniques like byte array to store priority and data compactly, enhanced efficiency and reduced memory bandwidth requirements. Performance impact. Queue size reduction, improved latency, enhanced throughput. These are the three performance impacts in the priority queue. Three traits of performance analysis. Key performance metrics. Latency. How fast high priority messages are processed. Improves due to early discarding of less important messages. Throughput. Total number of messages successfully processed may decrease slightly due to aggressive discarding but is more efficient. Fairness and starvation. Low priority queue measures might never be processed, must balance fairness and versus cruelty. Analysis of these three performance impacts and benefits of this priority queue is predicating behavior under load, which is essential in real-time systems. Real-world applications: network packet scheduling, event-driven simulations, AI search algorithms. This priority queue is used in real-world examples like network packeting and also in AI search algorithms. This processing, this priority queue is used, widely used. Synchronization in shared memory. Multiple threads processes across the queue. Lock-free algorithms and locks using automatic operators. It has some issues like contention can reduce performance. Lock-free queue improves concurrency but are more complex to implement. Applications and visualizing two discard levels. This diagram illustrates how to discard level activity, managing queue content. Critical items are fully processed, moderately prioritized items and handled with discretion, and low priority items are immediately discarded. Now coming to conclusion and applications as well. First we see where it is used: aerospace systems, automotive, ECUs, network routers. And coming to the conclusion, we can use this priority queue in real-time world as well, and it is mainly used in AI algorithms and network queuing and network routers as well. Thank you, ma'am. Thank you for listening me patiently. Thank you.